now show understanding of how factors contribute to the performance of the computer. How factors contribute to the performance of the computer. Now, what is the performance of the computer? Performance of the computer, as I said in the previous class, is not just that computer works fast. It's about overall throughput of the computer. All right. It really does not mean that if the computer can go fast, there might be lesser RAM or slower delivery of the data that might hinder the speed of computer. So performance of the computer. First, let's talk about the factors. Clock speed we discussed yesterday, and I want to discuss it again. So it is worth mentioning here the role of system clock first. The clock defines the clock speed. The clock defines the clock cycle, which synchronizes all computer operations. As mentioned in yesterday's lecture, the control bus transmits signals, ensuring everything is fully synchronized. I told you that what is synchronization, when few of the registers are working in a line and everyone knows that when the data will be delivered, all right, and how to work around it, a special purpose register, and when to deliver it further afterwards. So that working and taking of data and giving of data is actually done after the system clock. So if the system clock is slower, the clock speed becomes slower. When the clock speed becomes slower, this synchronization process becomes slower and the overall throughput goes down. So the control bus transmits timing signals, means that the clock signal arrives through control bus, which ensures the synchronization. By increasing the clock speed, the processing speed of the computer is also increased. All right. A typical value nowadays is 3.5 gigahertz, which means that 3.5 billion clock cycles per second. Although the speed of the computer may have been increased, it is not possible to say that computer's overall performance is necessarily increased by using higher clock speed. Other factors are, other than the clock speed, are bus width, processor type and number of cores, and cache memory or cache memory, whatever you call it. Other four factors used to be considered is also the bus width. Okay, so bus width is the width of the address bus and data bus that can affect the performance. Now, what is bus width actually? This is also called word size. When we talk about computer, you might have heard that someone says that I have got 32 bits computer, I've got 64 bits computer. Nowadays, commonly, the computer is actually 64 bits. What does it mean? It means that the width of the address bus and the data bus is actually 64 wires. And the size of the registers inside the microprocessor is 64. As far as the size of register is concerned, that might be different, but hypothetically, ideally, we think that way. But the size of the bus width for address bus and data bus is fixed. So what does it mean? It means that if the bus width for the address bus is 4, it means the highest address it can access would be 2 to the power 4. All right, 2 to the power 4 means 16 addresses, 0 to 15. If the bus width of address bus is 5, it means that it can deliver how many bits at a time? 5 bits, means 32 bits. means, sorry, 32 is the highest range, means from 0 to 31. So that is the highest address that you can access. Now let's say if the bus width is 32, means the address bus has got 32 wires in it. Address bus is a physical thing which is connecting the processor with the memory and other parts of the computer through the motherboard. Flies over the motherboard. When the processor is connected over the motherboard, then these buses are running along over the motherboard. So what I'm trying to say is, bigger the um, address bus width, higher the address that you can access. Now let's say your computer is 32 bits. So if your computer's bus width is 32 bits, if your computer's word size is 32 bits, in that case 2 to power 32. 2 to power 32 means 4 gigabytes, 4 GB. It means that if your computer is 32 bits and you have got memory installed 8 GBs or 16 GBs, that means that you won't be able to go beyond 4 GB. All right. But as we know that if you increase 1 bit, the capacity goes double. For example, in 1 bit you may have 2 values, but in 2 bits you may have 4 values, in 3 bits you may have 8 values, in 4 bits you may have 16 values. Similarly, if it is 32 bits, you may have 4 GB, in 33 bits you may have 8 GB, in 34 bits you may have 16 GB, in 5 bits you may have 35 bits you may have 32 GB, and similarly with every increasing bit, the capacity of the RAM that you can access as microprocessor gets doubled. So higher the bus width, more the data that you can access, more the addresses that you can access in computer's memory. This is actually very important concept, and we will discuss this concept when we will be studying indirect addressing again. So bus width means the number of wires. Every single wire represents a single bit in address bus and the data bus. Higher the bus width, more the data that you can bring into the microprocessor. All right. If the register is of the same amount of bits, then that data can be consumed in one go. All right. So width, bus width, or the word size is actually a very important factor for the performance of computer. And then we have got clock speed. Yesterday I discussed about overclocking. So clock speed is the speed of the microprocessor, and what they do, they set the BIOS for the clock speed which is not maximum for that particular microprocessor in your computer. So your computers are mostly a little underpowered. That is done to avoid any excessive heat generated through the microprocessor, so to have more life to your computer. But some gamers, they want to increase the speed of the processor, or few of the programmers, they wanted to for better processing. So what they do overclocking. So overclocking is actually the clock speed can be changed by accessing the basic input output system, which is BIOS. Yeah, and when you start your computer, you can hit F2. In some of the computers, if it is F10, whatever, different brands have different. I've got Dell computer, so F2 basically takes you to the BIOS. In BIOS, there is a setting that can be used to overclock your computer. However, using clock speed higher than the computer was designed um, um, for your better processing purposes, but that can lead to problems such as execution of instruction outside the design limit. So basically the idea is that everything should be done within the limit which is set by the company. And this execution of instructions outside design limits, which can lead to serious unsynchronized operations, might be clock running faster and the instruction cycle itself is slower. In other words, an instruction is unable to complete it before the next due clock cycle for the execution. And the computer would frequently crash and become unstable. So mind it that whenever you overclock, this might give rise to the troubles. You see, every instruction requires some time to complete. What if the clock cycle is going faster than that completion of the execution time for the single instruction? In that case, computer will not be able to cope up with the clock speed and the synchronization will be disturbed. When the synchronization is disturbed, computer will start crashing. Thirdly, the cache memory or the cache memory. Cache memory or cache memory, what does it mean? This is the memory inside the microprocessor. If you go into the BIOS or you go and see the specification of your computer, you might come across a type of memory which is L1 level 1, L2 level 2 and L3 level 3 memories. These are actually the memories inside the microprocessor. You see, basically what happens, there is a problem in von Neumann architecture, and that problem is the delivery of the data and instruction from the RAM to the microprocessor. Think of it this way. Let's say there are 100 nanoseconds for one instruction. Basically what happens that the delivery, the travel of the instruction from the RAM to the processor takes 99 nanoseconds. Nano is 1 billionth of a second. So when computer tries to load in fetch decode execute cycle instruction arrives in MTR in 99 nanoseconds. And when processor, because it is a speedy machine, it's a faster machine, when it executes it, it takes only 1 nanosecond. So practically, if you look into it, out of 100% time, 99% of the time, processor is waiting for the instruction to arrive. As soon as instruction arrives from the RAM to the processor, it is executed, and that execution time is only 1 nanosecond. If it is 1 nanosecond, it means that processor is practically 99% of the time sitting idle waiting for the data and instruction to arrive so that it can act upon it. So that is actually very important factor that you need to understand. It is called von Neumann bottleneck. So what is the bottleneck? That computer requires instruction to act on. That instruction when arrives, it arrives slow. It arrives slow, although it is fast in human terms, but in computer's terms, it is slow. So practically computer is just free. Remember, this is just analogy to make you understand. Practically computer is just free for 99% of the times. So what happens, no matter how fast the computer is, since it has to wait for a long time, a very, 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 very long time relative to the execution time, it has to wait. And that wait will keep the computer slower. All right. If you are given a work, only then you can do it. If someone says that, wait, we are delivering the work and you are waiting, you are doing nothing, you are idle. When you are idle, you are doing nothing. No matter how fast, how good you are still waiting. So for that reason, what happens, they have developed cache memory or cache memory, the memory inside the microprocessor. So what basically happens when the program at first starts, it brings not just one instruction. Since the processor is actually a sequential machine, operating system knows that after this instruction, the next instruction will be executed, then next, then next, then next, and in the series, what it does, instead of bringing in just one instruction, operating system now knows that processor has got its own memory called cache memory inside itself. It brings the bunch of the instruction from the instruction which requires to be executed and onwards, a bunch of instruction arrives in the microprocessor. That bunch of instruction is now in microprocessor, and the area where it is saved is called cache memory. Now from that cache memory, since the data has already, the instruction has already arrived, the data and instruction has already arrived, now it is at the disposal of the microprocessor. Now microprocessor will start one instruction executed, take second instruction and execute it, and by the time that cache is, the instructions in the caches are all executed, another bunch arrives. So the delay that was there for every single instruction that was making the processor sit idle for 99% of the times is actually now finished, and it is there just for the first time when the first bunch of instruction arrives. So when the program starts, this actually happens, and afterwards, because of the presence of this cache, doesn't happen. So processor then works at its full capability. Before that, it was just waiting for every other instruction to be at its disposal. So the use of cache memory can also improve processor performance. It is similar to RAM in that its content are lost when the power is turned off. Cache uses static RAM, SRAM, we will discuss about it, SRAM later. Whereas most computer uses DRAM for the main memory. So the main memory RAM is DRAM, which is dynamic RAM made up of capacitors, and inside the computer, the microprocessor, the RAM is SRAM, which is static RAM. It is made up of certain types of gates, which are called universal gates. If you do remember from your logic gates, these are either not AND or not OR gates, and the name of the circuit is called SR flip-flop or JK flip-flop, and these flip-flops are made up of NAND and NOR gate, and they are used to keep the data. So therefore cache memory will have faster time access since there is no need to keep refreshing, which slows down the access time. When a processor reads memory, it first checks out cache and then moves on to main memory if the required data is not in the cache. The cache memory stores frequently used instructions and data that need to be accessed faster. This improves the performance. All right, this improves the performance. Now, the DRAM has capacitor, and we know that this device capacitor will lose its energy with the passage of time. If it loses its energy with the passage of time, computer needs to refresh it. That refreshing in the main memory also hinders the performance of the microprocessor because that refreshing takes time. That is because the main memory is made up of capacitors, not NAND or NOR gates, SR or JK circuits. So that is one factor. The other factor is the amount of time that it takes to reach the microprocessor. In order to overcome these two, a bunch of the instruction arrives in cache. So whenever processor requires data and instruction which are necessary for the processor to go on, as we know from this fetch, decode, execute cycle, they are now in cache. Processor checks in cache. If it is there, it accesses directly. Or by the time that cache is lapsed, used, another bunch of data and frequently used data and instruction arrives in the cache. So that is actually one thing. The fourth factor is, we discussed about bus weight, we discussed about clock speed, we discussed about cache memory. Now let's talk about processor and number of cores. The fourth factor is the use of different number of cores. The core is made up of an ALU, a CU, and registers. arithmetic logic unit, control unit, and registers. Means cores are actually nowadays a full-fledged computer, and the jacket that you see, the processor, when you purchase a processor, it's something 2 by 2 inches, but there is not a single processor. This is actually a jacket. Inside that jacket there are multiple processors. As I told you in my previous lecture, that the processor is so small, it is sometimes 1/4 of my fingertip. It might be smaller than that. So over that jacket there are multiple processors, and these processors are actually wired together so that they can be controlled and they can share their work. So those ALU, CU, and registers combinedly is one core, and there are multiple cores in that jacket that you see nowadays for AMD Athlon, for AMD other processors, and then i5 and i7s, i3s, i9s. They all have got a different number of cores in it. The use of different number of cores, one core is made up of ALU, CU, and registers, can improve, number of cores can improve computer performance. Many computers are dual core. Dual core means the CPU is made up of two cores, or quad cores. Quad cores means that the CPU is made up of four cores. The idea of using more cores alleviates the need of continually increasing the clock speed, since these cores can distribute their work and they can concurrently simultaneously perform the tasks. However, doubling the number of cores does not necessarily double the processor performance, since we have to take into account the need for the CPU to communicate with each other. This will reduce overall performance. All right, now what basically happens, let's say I have got two cores and I need to add four numbers. If it would be a one core thing, I will take one number, then take second number, add it, two operations. Then I will take third number and add it, three operations. And then I will take one number and add it, four operations. Four operations, four instructions. Four instructions means more instruction cycles and more clock cycles. Let's say I've got dual core computer. Dual core means I have got two cores. Now I will take two numbers and give it to one computer, the one core, one CPU core, other two number, and I'll give it as operating system to another core. Now, first core, while it is taking first number, second core is taking third number. First core, while it is adding second number to first number, second core is actually adding fourth number to third number. Means now the instruction that was being taken in 4 clock cycle or instruction cycle is now being executed in 2 clock cycle. But the thing is, because they both are working at the same time, but the thing is, you need to have a result of all 4 numbers. Then the number from the first core and number from the second core, the addition of the 2 numbers from the first core, the addition of the 2 numbers from the second core will be taken and given to first core. Now first core has got 2 numbers. So it will take first result of the first core and it will take second result of the second core and add them up. So how many instructions are there which are executed as per the time? 2 first, because they were concurrently done, and 2 later. So overall time, how much time has been taken? Same. If it would have done by one processor, it is 1, 2, 3, 4 instruction. If it is done by 2 processors, earlier they took 2 instructions each at the same time. So we will just count 2 instructions. But when these 2 results need to be combined, they will be again given to the first core and they will add it again 2 instructions. So the number of instructions remains the same. So increasing the number of core is actually not the guarantee that the overall performance will be increased. But if it happens for larger numbers, then definitely there will be an advantage. So let's say if it is 100 numbers that are required to be added, and we have got 4 cores. So what will happen? First core is given 25 numbers, 1 to 25. Second core is given 25 numbers, 26 to 50. Third core is given 25 numbers, 51 to 75. And fourth core is again given 25 numbers, 76 to 100. They will add all these numbers concurrently, simultaneously in 25 instructions. So when 25 clock cycles are performed or instruction cycles are performed, all these 100 numbers are added by their respective cores. But now the cores have got 4 results: 1, 2, 3, 4. First core has got result for first 25 numbers. Second core has got result for second 25 number. Third core has got third 25 numbers result addition, and then fourth core has got last from 76 to 100 numbers addition with it. So these are 4 results. So these 4 results will again be taken 2 and 2, given to 2 different cores, and then these will be finished in 4 instructions. So overall 25 plus 4, 29 instructions were taken to add up how many numbers? 100. Had that been a single processor, it would have taken 100 cycles. With 4 processor, it had taken 29 cycles. Now, since the number of additions has improved, the difference in the performance you can see. If it is 4 cores, it is 29 instructions that were used to add 100 numbers. Otherwise, it was for lesser number of instructions is the same. So when the work grows, the performance improves, but otherwise it does not. So the use of a different number of cores can improve processors or computers' performance. Many computers are dual core, means 2 cores, few are quad cores, which are means 4 core. The idea of using more cores alleviates the need to continually increase the clock speed, because clock speed basically gives rise to heat as well. However, doubling the number of cores does not necessarily double the computer performance, since we have to take into account the need for computer CPU to communicate with each other. So if they won't communicate properly in time, it would be difficult. This will reduce overall performance. For example, dual core has 1 channel and needs the CPU to communicate with both cores, reducing some of the potential increase in its improvement. Channel means the connection between 2 cores. So if a control unit wants to communicate with another, or the operating system wants to talk to other processor, but that wire, the channel, is being used by the first processor, operating system would have to wait to go to second, because there is just 1 channel that is being used for both the processors. So that might be a problem. Quad core has got 6 channels. 6 channels, how, let's say these are quad core, 1, 2, 3, 4. So they are connected 1, 2, 3, 4 with 4 wires, and then they are connected diagonally as well, 5 and 6. So 1, 2, 3, 4. So they are connected like this, and then diagonally as well. So it is now 6 channels. So connecting with any processor for quad core becomes easier. But if it is just 2 computers, there is 1 channel connecting that. So if it is 1 channel and processor wants to communicate with second core, but the first core is actually holding up that channel, it means that operating system would have to wait. So that is how it works. All of these factors need to be taken into account when considering computer performance. So that is actually for the computer's performance. Now, understand how different ports provide connection to peripheral devices, including USB, HDMI, VGA. So this VGA and HDMI is added to this particular new syllabus. Otherwise, only USB used to be there. All right. So what are computer ports? Let's first discuss them. What are computer ports? You might have seen several ports on your computer and your cell phone. Like this cell phone has got USB-C in it, USB-C in it, but there are conditions when you would have seen USB-A, the bigger one, or other ports like VGA and all. So we are quite used to with these. Over the desktop, you might have seen, or your laptop, you might have seen VGA and HDMI as well. So input and output devices are connected to a computer via ports. Remember, ports are not just those which you see over the casing. Ports are sometimes inside the chassis or chassis, inside the chassis as well, that computer's box, system box. All the devices inside the system, like the hard disk, it is connected over using a port as well over the motherboard. So everything which is connected, which is not part of the processor, is connected to the processor using a port. When you connect it, basically you are giving it under the control of microprocessor. So all those devices which are outside the microprocessor, except RAM, because that is the part of microprocessor, all those devices, when they're connected to the port, actually they come under the control of microprocessor at the discretion of the microprocessor, so that microprocessor could use it. When does it use it? It uses it when you ask for it. If you want to open a file from a hard disk or from SD card or from another computer over the internet or your local area network, the processor wants to access it. If processor wants to access it and it is available, it is only through ports. So input and output devices are connected to a computer via ports. The interaction of the ports with connected input and output is controlled by the control unit. All right, so mind it. So interaction of the ports is actually controlled by the control unit. You might have seen the HDMI port, the USB-C port. Your computer uses different types of ports, the VGA ports. So let's first discuss USB port. Universal serial bus port. The universal serial bus is asynchronous serial data transmission. Asynchronous serial data transmission means what? It means a type of data which actually is not in sync. Rather, a signal first goes and tells that the data is actually going to be arrived, and when data is arriving, there is no synchronization. The speed of the data is different. When the whole data is arrived, another signal comes that now the data has arrived. We will discuss about it. The USB is an asynchronous serial data transmission method. It has quickly become the standard method for transferring data between computers and number of devices. All right, the USB cable consists of 4 wired shielded cable with 2 wires for power and the earth, and 2 wires used for the data transmission. So it is actually possible, like I have connected my phone over here with this USB-C. This is USB-C and this is my phone. So what is basically happened while I'm accessing data from this phone through my computer, I am also basically charging my phone, because 2 of the wires, which are actually earth and power, can be used for charging. So I am charging, and if I want to access the data on the phone, I can do that as well. So that is the beauty of USB cable. When the device is plugged in, like my cell phone, I just showed it to you, into a computer using one of the USB ports, the computer automatically detects the device that is present. This is due to the small change in the voltage level on the data signal wire in the cable. All right, so the cable's data signal wire, the voltage over that wire gets changed, and from that change, computer senses that which device it is. The device is automatically recognized by the operating system then, and the appropriate device driver is loaded up so that computer and device can properly communicate. All right. So If the new device is detected which was not previously detected, in that case the computer will look for the device driver. Mostly the device drivers are present at the time of installation of the devices in the Windows operating system or the Mac operating system. If it is not, then system asks for it. All right, or system downloads it from the website of the vendor. The USB system has become the industry standard, means every other devices nowadays. When I was of your age, I still remember that at the back of, we did not have these laptops, we had just desktops. So at the back of the desktop, there were so many ports, so many ports. One port is for keyboard, the other one is for mouse, for the VGA, for LPT one for the printer, and there are so many others. Okay, so for every different type of the device was using a different kind of port. Since the inclusion of this USB and the standardization of it, now almost all of the devices, they are using USB ports. And one good thing about USB port is that it can be used like power extension. You know what power extension cord and the system is? You plug it to the power and then you have got this extension and you put several plugs, so you are sharing the power. Similarly, one port can be used to share as many as 128 devices, but you need to mind it that since these devices are also drawing their power from the port, so port might be able to deliver the data, but power, since the power will be shared among the ports, device might not work. So not many, but devices can be shared as many as 128. So there are actually advantages and disadvantages. Let's first see what are the advantages. Devices plugged into the computer are automatically detected and device drivers are automatically loaded up. The connectors can only fit one way, which prevents incorrect connections being made. Means two of the sides are actually different. If it is USB-C, then USB-C on one device and USB on other device, you cannot actually reverse it. It would go the same way because the port shape is different. But the standard is same, USB. This has become the industry standard, which means the considerable support is available now to the users. Several different data transmission rates are supported. All right, it is up to 5 point something GB with USB-C and USB 3, 3.01. Newer USB standards are backward compatible always. So if you are connecting a USB 2 port with USB-C, that is fine. If you are connecting USB 2 with USB 3, that is fine as well. So they tame down or speed up themselves. These were the advantages. Now disadvantages. The present transmission rate is limited to 500 megabits. All right. The maximum cable length is presently about 5 meters. If you go beyond 5 meters, you might have trouble for USB. The older USB standards such as 1 or 1.1 may not be supported in the near future. So that is fine because I have not seen any cable or port which is still using USB 1 standards. All right. So that was USB. Now let's talk about HDMI. High definition multimedia interface. This is one best thing that has occurred. It is actually a real good thing nowadays. Every computer, every modern computer or laptop is equipped with it. So it can carry data and voice and video signals, but I have not seen it that people are using for that for this thing for data transfer. Rather, they are basically using it for multimedia transmission. The high definition multimedia interface ports allow outputs, both audio and visual, from the computer to HDMI enabled devices like TVs and monitors and multimedia projectors. They support high definition signals, enhanced or standard. High definition signals, they might be controlled. Sometimes they are enhanced or they are sometimes standard for the devices. HDMI was introduced as a digital replacement for the older VGA analog system. VGA, you might have heard of it, all older monitor, those thick monitor with CRTs inside it was VGA enabled and it was analog. So HDMI actually has digitized version. Modern high definition televisions have the following features which are making VGA a redundant technology. Now, what are those features? They use widescreen formats, 16:9 ratio. All right, that is not possible with VGA. The screens use greater number of pixels, typically 1920 and 1081. This is called uh, full HD or 1080p. All right, this is called full HD or 1080p. And sometimes nowadays we have got this 4K as well. So HDMI actually supports 4K. So the faster frame rate as well, sometimes and refresh rate. So sometimes refresh rate goes, nowadays you might have heard that 90 hertz refresh rate is going to be common, 120, and few of the phones have gone more than 120 hertz refresh rate and more than 120 frames per second. So this can only be actually supported by HDMI and not VGA. The range of colors is extremely large. Some companies claim up to 4 million different colors of variations, and VGA can only show less than that, maybe 256 colors or 65K colors. This means that the modern television require more data because they have capability of larger screens, more pixels, more frames per second, more refresh rate. They require more data, and more data cannot be delivered using VGA, so it will be actually delivered using HDMI, which has to be received at a much faster rate. That more data is also needs to be, since you know that video and sound are actually time bound, they are time dependent. If you won't deliver them in the given time frame, you would see a flickering video or a choppy voice. In order to avoid it, what basically happens, you have to deliver the data faster. So you need more data at faster speed, and that it can only be done using HDMI. So HDMI increases the bandwidth, means the amount of data in a unit of time, making it possible to supply necessary data for high quality sound and visual effects. HDMI can also afford some protection against the piracy since it uses high bandwidth digital copy protection. So HDMI is also preferred by few of the vendors. So high bandwidth digital copy protection, or HDCP, uses a type of authentication protocol, and that authentication protocol can be used. And you might have heard of the Blu-ray. Few of the Blu-ray discs are actually copyright protected, and if they are actually pirated, they don't work. A Blu-ray player will check the authentication key of the device that is sending the data, such as high definition, that it is sending the data to. If the key can be authenticated, then handshaking takes place, otherwise system will deny that this DVD cannot be played back. So HDMI is used with the HDCP, high bandwidth data copy protection, and that is used by many Blu-ray DVD producers in order to protect the piracy. Then comes video graphics area, VGA card. As we have discussed about it, that it is actually older standard. It was not digital, it was actually analog, and that was not able to send more data over faster rates. And the data required to be converted to analog form before it was being sent. So the typical size was just 640 by 480, 640 by 480 pixels, and nowadays we have got 3280 multiplied by 2600 something, that is all 4K. So we need to deliver a lot of data. That is only possible using HDMI, but not VGA. VGA was introduced at the end of 1980s. That was itself a blessing that time. VGA. VGA was introduced at the end of 1980s. VGA supports 640 by 480 pixel resolution on a television or monitor screen. It can also handle a refresh rate up to 60 hertz. All right, and 60 or 60 frames per second. Provided there are only 16 different colors being used. Only 16 means the color number of bits for color were just 4. If the pixel density is reduced to 200 by 320, then it can support up to 256 colors. So means that you have got only a certain number of content units that can be delivered in time. So if you want to deliver more colors, you would have to decrease the number of pixels. And if you want more pixels, then you would have to decrease the number of colors. In any of the cases, basically a VGA card and VGA port were not able to deliver more than that. The technology is analog, and as I mentioned earlier, is phased out. Now, I don't see any more VGA monitors or televisions. They all are now either LCD or LED. So let's summarize the pros and cons of HDMI and VGA. So the pros of HDMI are that the current standard for modern television and monitors are HDMI. These are the advantages. Allow for a very fast data transfer rate, improved security, support modern digital systems. But there are disadvantages of HDMI as well. Not very robust connection, easy to break, sometimes it flickers. Limited cable length to retain good signal. Larger the cable, signal will become weak. So if the cable is made from some unknown vendor, in that case, you might see an image or sound which is not at par even. There are currently these issues with HDMI, and let's see what are the advantages of VGA. Those advantages or disadvantages are now all gone because the technology is almost phased out. VGA was a simpler technology, it is advantage. Only one standard available, there were no changes. All right, and in HDMI there are 5 different standards are being used. Mind that this could be a disadvantage, that in HDMI there are 5 different standards are being used. So it is possible that the cable that you have purchased would have a different standard used for making it, and the device that you have will be expecting a different standard. So these 2 different standards might be actually, when you connect a different standard based cable to a different standard based port, the data will be delivered, but the output would be poor. In VGA, there was just one standard. So if there is a device and there is a cable, they all are made just out of one standard. In VGA, it is easy to split the signal and connect a number of devices from one source. So I have seen these splitters where you have got just one desktop machine, and there is splitter. All right, that splitting machine can actually send the data to different monitors, or it can split the output to different monitors. So that was also possible. And the VGA connection was actually very secure. The disadvantages are that first of all, VGA itself is outdated now. It is easy to bend the pins when making connection. Oh God, That was something very, very, very common. So if you are a bit uh, uh, means you when you are pushing your cord or connector to the port and you are basically not at the exact location, so one of the pin does not go to its own hole, the pin will be then stumbled. All right, and then I'm using my pen and pencil to straight it up so that I could actually push it against the port and all. So that was one very common thing, and we had to actually change the cable most of the time. Still, at few schools and at few tuition centers, I do see that the multimedia monitors are still having these VGA ports, and since the HDMI cable is costlier, it is expensive than VGA cord. Many of the institutions is still supporting VGA. So HDMI port is expensive, HDMI cable is expensive, and VGA cables are basically very cheap. So if in VGA, the last thing, if it is VGA and you want a good output, or at least the output to the fullest, you had to actually pay for expensive cables, because these ordinary cables were not able to deliver the proper data. And it is not the case for HDMI, even if it is from a cheaper source, or it is not that good, but still the least amount of data which is being delivered is so high that you actually won't feel much of the difference. But that was not the case with VGA. So this was just the theory part today that we have discussed. We first discussed that factors that contribute to the performance of the computer, and then we discussed that what are the codes that computer uses to deliver the data and all. Now from the next lecture, we will start the practical part of it. We would have so many things to discuss, and then we would have the whole assembly language to understand and read the programs from. And there is another part which was earlier in A2's bit manipulation, and we would have an extended version of our assembly language commands for bit manipulation as well. So that's about it. If you have any question related to this, or you can go through this in your syllabus and understand it easily.